Here's just a little interesting video to show you the framework for bargaining, where we have parties to a process of cooperation that generates an output, and this output can be allocated to the different parties. Here, two people, person one, person two, and we can show the utility derived through these different possible allocations of output. Utility derived by each party, we get what's called a utility possibility set. Here is the fallback position, U star, which is the outcome that you get, that you end up with without cooperation. The utility possibility set here is U, capital U. Now, what we're looking for here is the solution to the bargaining problem, which is a particular point inside U. So we refer to F of the utility possibility set and the fallback position U star. This is the solution to the bargaining problem, and it's an element of the utility possibility set. It's one possible allocation of utility amongst the parties. So we have different properties that should be met by a desirable bargaining outcome. The first property is Perito optimality, which simply means that the outcome, the bargaining outcome, should be on the frontier, on the Perito efficient frontier, so as to maximize the utility available to both parties. If you had an interior solution, outcome would not be Perito efficient, because it would be possible to increase the utility of one party without decreasing the utility of the other party. So this is very straightforward, the Perito optimality condition. So the second requirement is that if the utility possibility set is symmetric, then the payoffs must be equal. The gains from cooperation must be split equally. What does it mean for the utility possibility set to be symmetric? It means that the set remains unaltered under permutation of axes. So for any possible combination or any possible point in the utility possibility set xy, which is in U, yx must also be in U. It must also be in the set. So here I've illustrated this particular point here is in the set. The permutation yx must also be in the set. So if that's the case, then the set is symmetric. It's a symmetric set. It remains unaltered. We can permutate the axes, which means that we can view these agents as identical. And if these agents are identical, then the solution must be an even division, which means that the solution, the bargaining solution, must be on the xy axis. Right? So the bargaining solution is here. It's on the Perito frontier, and we also have this equal split of the gains. And this is, of course, the xy axis here. So the property of invariance to linear transformations of utility functions has two separate components. The first is the independence of utility origin, where we can independently change the point of measurement in terms of the origin for the utility function for each party, and we can do this separately for each party without changing the bargaining solution. So we have I persons here, party to this bargaining process. We can define a vector alpha with I entries, which is an element of Ri. and we can redefine U prime, which is the new utility possibility set where the utility of each party has been increased by some alpha. And this is being done for all utility vectors in our utility possibility set. So this is U prime. Well, the bargaining solution does not change. Meaning what? Meaning that F for U prime, where the point of origin is changed, right? We're adding some alpha number to the utility of each party. This is none other than the original bargaining solution plus alpha, and this is true for every person. I think I need to add a subscript here. So this is the independence of utility origin. Says that basically the bargaining solution does not depend on absolute scales of utility. And in fact, we could normalize all problems to U star equal to 0, so that F U star simply becomes F of U 0. The second component to the invariance to linear transformations of utility functions is the independence of utility units. Independence of utility units, which means that the bargaining solution is invariant to changes of the measure of utility unit which is being used to represent the party's utility. So the key idea here is that the bargaining solution does not involve interpersonal comparisons of utility, because we can freely choose to represent utility of the parties differently. I'll come back to this point. So what are we saying here? Technically, we're saying that we can define a vector beta, which is a series of number which has I entries. It's an element of Ri. Beta, all the betas are positive numbers. We can redefine a U prime, which is the new utility possibility set where the utility of each party has been multiplied by some number, beta 1 through beta I. So the utils which are employed to measure the utility of each person are being multiplied by some factor, some beta, but the solution is not influenced by the change in this measurement unit. And this is true for each person in this bargaining process. So again, this is the claim here is that this independence of utility units combined with the independence in utility origin together rules out interpersonal comparisons of utility. And this claim, as Sanjay's lecture explores, is actually rather controversial. We argue that the Nash bargaining solution, which is claimed to be invariant, well, is invariant to linear transformations of the utility functions of the parties, still involves some commitment to the underlying representation of the individual's preferences. I encourage you to watch Sanjay videos where he shows you that in some sense the Nash bargaining solution does involve some kind of interpersonal utility comparison. This is to be developed further later on. Final condition here is the independence of irrelevant alternatives, which is the idea that if the bargaining set shrinks such that all the options in the new set were also in the old set, then the bargaining outcome should stay the same. So here is a bargaining set. And here is the bargaining solution over this utility set U. Consider U prime, which is included in U. Sorry. So U prime might look something like this. Right. And further assume that f of U prime, f of U, the original bargaining solution f of U is an element of U prime, right? So it's still achievable in U prime. What the independence of irrelevant alternative says is that f of U prime must be f of U. The bargaining solution is unchanged. So if f of U maximizes some kind of welfare function defined over U, then it must also maximize some welfare function defined over U prime as long as U prime is fully included in U.